Nearly every one of your science classes starts off with the scientific method. You recognize this? Ask a question, form a hypothesis, perform an experiment, collect data, draw conclusions, and then memorize a bunch of facts. This is really boring. Science is not a simple recipe in a cookbook, and learning is not memorizing facts for tests. Yet that's exactly what we do. We have to change this. We have to look at how curiosity can ultimately benefit society by looking towards tomorrow, by going through a path from involvement to imagination to invention to innovation. And I'd like to illustrate this by telling you the real story about how we discovered how geckos stick. First, you need to get involved. You need to do curiosity-driven research yourself. We know that learning by being an active researcher is the best way to learn. Imagine being in my lab and trying to discover how geckos stick. Here's one of our subjects. This is a crested gecko. We're going to put the gecko on glass, and we're going to use the high-speed camera that can capture up to 1,000 pictures in 1 second. There he goes. Okay, recorded. There's the animal's toes.
So how do their feet stick and unstick so quickly?
How do they do this? We wondered. It's kind of crazy, right? It's hard to believe. Well, it turns out it was already known that the geckos have hairy toes. And those hairs are really small compared to your hair. And the little tips at the end are even smaller. Well, my student Tanya, who was not much older than some of you when she did this, a sophomore undergraduate, tried to figure this out. And we told her that in order to do this, you'd have to measure the force of a single hair. Now, we kind of only did this jokingly because these hairs were so small, we didn't think it was possible. But Tanya didn't know that. And she went on to build the simplest, most beautiful measurement device ever. Here it is. She took one of those tiny little hairs and put it onto a probe. And then she began pushing it into the metal beam. Now, she was very frustrated. For months, it didn't stick. But she figured out she had to orient it just like the gecko grabs on. And then it worked. And there's the little split ends grabbing the beam in that little window. And then she did something magical. For the first time ever, she measured the force of a single gecko hair that allowed her to discover a completely new way to stick to something no human has ever known before. They have hairy little toes, huge numbers of hairs, and each hair has the worst case of split ends possible, 100 to 1,000 nanotips that an animal has on one hair, and 2 billion total, and they don't stick by glue or by suction or by Velcro. She discovered they stick by intermolecular forces alone, by van der Waals forces, and you'll learn this in chemistry and physics if you take it. It's unbelievable. It's a whole new way of thinking about making an adhesive. Well, this is the end of the story. There's still mysteries. Why are the gecko's feet looking like this? They have bizarre toes, and we don't know why. If you go into a museum and look at each gecko species, you see they have all different hairs, different lengths and thicknesses and patterns. Why? I don't know. But you should come to Berkeley and help me figure this out. It's just about right, so apply. But it's a mystery. And there's even more stuff that's unknown. This tarantula also has hairs and can stick this way too. But recently it was found that they also can secrete silk from their feet, not just their behind, like you know they do. And even more recently, my graduate student Anne showed that all spiders can secrete glue. And we know nothing about this glue. Except it was around way before this guy, millions of years before. So don't stop at the discovery. Next, imagine the possible uses for society. Here is the first human supported by a gecko-inspired adhesive. This is my former graduate student, Keller Autumn, who's a professor at Lewis and Clark, offering his second-born child for the test. And she's a very good sport. Now imagine all the things you could make from this, not only adhesives, but products in sports and biomedicine, technology, robotics, toys, automotive, fashion, clothes, and yes, even hair pieces. I swear to you, we got a call from Michael Jackson's hairdresser about hair pieces before he passed away. Who would have guessed from studying geckos? Next, invent a game-changing technology, device, or product. Like my engineering colleague at Berkeley, Ron Fearing, did when he made one of the first synthetic, self-cleaning dry adhesives after the simplest version that you see in animals. Believe it or not, right now, because of this work, you can make your own synthetic gecko nanotape by nanomolding with just a few parts. And here's the recipe that we can give you. It's been incredible since we made this discovery of all the papers and the work and the different ways to make it. It's emerging into a billion-dollar industry. And who would have imagined that it started because we were curious about how geckos can run up walls? Next, you need to innovate. Create a business that ultimately benefits society. Did you know there are 6 million people per year that have chronic wounds? 2 million develop an infection, and infections account for 100,000 hospital deaths. Imagine if you could build a company that could produce a gecko-inspired Band-Aid that would remove pain and suffering. Just a simple invention. If you look at the last 3 great earthquakes, over 700,000 people were trapped and lost their lives. Imagine a company that made a search and rescue robot inspired from a gecko that could move anywhere and quickly find individuals that have been trapped, that sometimes survive as long as 2 weeks. There's the gecko-inspired robot, StickyBot, from the Stanford group that can grab onto any surface. Now, we ran our own for TED mini bio-inspired design challenge to get you to think about these kinds of products. We have a winner. Here's the winner. The winner came up with this design called Sticky Seat. Really clever. It's a seat that's not only comfortable, but it aids a seatbelt if you were in an accident in terms of keeping your seat and moving. This is brilliant. We didn't think about this, although we might think about patenting it now. But there's a winner for this. And the winner, and you can't make up something like this. The winner's name is Harry. Where is Harry? Harry, come here. We have a prize for you. Where's Harry? Over here. Harry, come here. We have a crested gecko for you that has very cool hairs on it. Congratulations for Harry. Excellent job. So don't worry, if you missed out on this, it's okay because we're doing another design challenge working with the San Diego Zoo. They're developing a Best Ideas project in San Diego, but it's going to go national. And I'll leave you with the fact that you should keep being curious, because curiosity-based research leads to the biggest benefits, as we showed you in our example, and you can make a difference. Now, because like Tanya, you don't know what can't be done. Thank you.